Welcome back, everybody. Today, we're going to be taking a deep dive into the fascinating world of superposition of pulses. And the main source that we're going to be looking at for this is a website called Open Educational Resources, Open Source Physics at Singapore.
Okay.
And they have this really cool interactive simulation that really caught my eye. And one of the things that I thought was really interesting is if you go on their website, they actually list Superposition 1 as a popular tag.
Oh, wow.
Which makes me think that this is a concept that a lot of people are curious about, and for good reason.
Yeah, it's a really fundamental concept in physics.
Right.
But it's also something that you experience all the time without even realizing it.
Oh, really?
Yeah, like if you think about listening to music on your headphones,
Okay.
that's superposition in action. Or even just the colors that you see around you, that's also based on superposition.
Okay, so clearly it's more than just a theoretical physics term.
Yeah.
Can you break down like what it actually means?
Absolutely.
Yeah.
So in the simplest terms, superposition is about how waves interact with each other.
Okay.
So instead of like bouncing off each other like billiard balls,
Right.
waves actually pass through each other. But as they're passing through their amplitudes, so basically their heights combined at each point where they overlap.
Okay.
So imagine like two waves traveling towards each other. If both waves have a peak at the point where they meet, that peak gets even higher.
Oh.
And that's called constructive interference.
Okay.
But if one wave has a peak and the other one has a trough, they can actually cancel each other out, and that's destructive interference.
That's a really good explanation.
Thanks.
So you're saying that the resulting wave is basically the sum of the individual waves.
Exactly.
At each point in time.
Exactly. And this principle applies to all kinds of waves, not just water waves, like light waves, sound waves, even seismic waves.
Okay.
They all exhibit superposition.
So that's why noise-canceling headphones work. They create a wave that's exactly opposite to the noise canceling it out through destructive interference.
Exactly. And that's just one example of how understanding superposition can have practical applications.
That makes me even more curious about this simulation.
Yeah.
I'm ready to see this all in action.
Let's take a look. So the simulation allows you to create different types of pulses on a virtual string
Okay.
and observe how they interact when they collide, so you can control the amplitude, the shape and direction of the pulses,
Okay.
and you can see the resulting waveform in real time.
So instead of just reading about superposition in a textbook, we can actually play around with it and see it happen right before our eyes.
Precisely. And that's what makes interactive learning so powerful.
Right.
It allows you to develop an intuitive understanding of the concepts
Yeah.
by experimenting and observing the results firsthand.
Before we jump into the simulation itself, I did want to touch upon something else you mentioned earlier about this website that's providing this Open Educational Resources, Open Source Physics at Singapore website.
Yeah.
I'm curious, what makes this website stand out? Is it just the simulations?
The simulations are definitely a highlight,
Okay.
but there's so much more to it
Mm-hmm.
that it's this amazing hub for open source physics education. The fact that it's translated into multiple languages already tells you a lot about their mission
Right.
to make knowledge accessible to a global audience.
Okay.
And the fact that they provide the source code for these simulations
Yeah.
means that anyone can modify them or even use them to create their own learning tools.
So it's like a collaborative effort to make physics education more engaging and accessible to everyone.
It really is, and I think that's a testament to the power of the open source movement.
Right.
It's about sharing knowledge freely, building it on each other's work, and constantly pushing the boundaries of what's possible.
I love that it definitely fits with the spirit of our show. Exploring and sharing knowledge in a way that's both fun and insightful.
And speaking of exploring, I think it's time we finally dive into this simulation and see superposition in action.
Let's do it. All right, so we're looking at the simulation now, and it's pretty straightforward visually, but I have a feeling things are going to get pretty interesting once we start playing around with these pulses.
Yeah, it is deceptively simple.
Okay.
You essentially have these two lines representing a medium like a string,
Okay.
and you can create pulses. Think of them as little bumps or disturbances that travel along the string.
And we can change like how these pulses look, like how big they are and which way they're going.
Exactly. You can adjust their amplitude,
Okay.
which is basically their height, their shape, and even whether they're traveling to the left or right.
Okay.
And then you can watch them collide and see how they interact based on those variables.
Okay, I'm already creating pulses and smashing them into each other. It's fascinating to see how they don't just bounce off each other, but actually like pass through like ghosts. But as they're passing through, the combined pulse is, well, exactly what you described earlier.
Right, the amplitudes add up at the point of intersection.
Okay.
So if two pulses are both traveling upwards and they collide,
Yeah.
the resulting pulse at that moment is even taller
Right.
than the individual pulses.
Yeah.
So that's constructive interference, creating a bigger wave.
But what if we send a pulse traveling upwards and another one going downwards?
Yeah.
What happens when they meet?
That's where things get really interesting.
Okay.
You can actually see them cancel each other out,
Mm.
at least partially as they overlap.
Okay.
And that's destructive interference. So imagine like two people pushing on a swing from opposite directions.
Right.
They're essentially working against each other.
Wait, so if that's happening with sound waves all the time, does that mean like our ears are constantly experiencing this superposition phenomenon?
Absolutely. Every sound you hear is the result of countless sound waves, some reinforcing each other, some canceling each other out, all combining to create this complex soundscape that you perceive.
That is mind-blowing.
Yeah.
I'm starting to see how this seemingly simple concept has such profound implications in the real world. Earlier, we talked about noise-canceling headphones, but what are some other examples of superposition at work?
Well, musical instruments rely heavily on superposition.
Oh, okay.
So when you pluck a guitar string, for example, you're not creating just a single wave,
Right.
but rather a whole series of waves with different frequencies and amplitudes all superimposed on top of each other. And the specific combination of these waves is what gives the instrument its unique sound.
And so each instrument creates its own unique fingerprint of superimposed waves.
Precisely. And this principle extends to all sorts of other fields, too.
Okay.
So in optics, superposition is key to understanding how light waves interact to produce different colors and patterns.
Right.
It even plays a role in things like radio communication and medical imaging.
It's incredible how a single concept can weave its way through so many different areas of science and technology.
It really speaks to the elegance and interconnectedness of the natural world.
Yeah.
Often the most fundamental principles have the most far-reaching consequences.
Earlier, we talked about how this website is this treasure trove of physics resources. And I can't help but think back to that long list of simulations in the NFAC section.
Yeah.
After playing around with this superposition simulation, I'm even more curious about what other, hidden gems are buried in there.
Well, remember that title that caught your eye?
Yeah.
A theoretical and computational analysis of oceanic tides.
Right.
That one dives into how the gravitational forces of the Earth, Moon, and Sun all interact to create the complex patterns of tides we observe.
Right, and I remember you mentioning that it uses computational models to simulate tides, which is fascinating to me. It makes me think about how computers are becoming increasingly important tools for understanding and predicting complex physical phenomena.
Absolutely. Computational physics is a rapidly growing field, and websites like this one are playing a crucial role in making these tools accessible to a wider audience.
Another title that stood out to me was Building the Singapore Young Physicists Tournament, SYPT Juror Assignment Web App, which, from what I understand, is a competition where students present solutions to open-ended physics problems.
Exactly. And it's inspiring to see a website dedicated to supporting students who are passionate about physics and who want to push the boundaries of their knowledge.
It's fantastic that the website caters to such a diverse range of interests and skill levels.
Yeah.
You have everything from simple simulations for those who are just starting to explore physics, all the way to complex computational models and resources for competitive physics enthusiasts. It truly seems like there's something for everyone here.
And that's the beauty of open source education. It removes barriers and makes knowledge accessible to anyone who's curious and wants to learn, regardless of their background or level of expertise.
Speaking of access to information, I also wanted to touch on the fact that the website is translated into so many languages. That really stood out to me.
It's a powerful statement about their commitment to making physics education truly global and inclusive. They're not just sharing knowledge within a specific community, but rather opening it up to the entire world.
And the website statistics we saw earlier, the millions of page views, are a testament to the fact that people from all over the world are engaging with this content.
It's a clear indication that there's a real hunger for high-quality, accessible STEM education resources.
Right.
And this website is filling that need in a remarkable way.
Before we wrap things up, I wanted to revisit that popular tag section we briefly touched upon earlier.
Sure.
I'm really curious to dig into those a bit more and see what they can tell us about the broader trends and interests within the online STEM learning community.
Let's dive into those tags and see what insights they can offer.
Okay, so we're looking at the popular tags section on the website, and it really is like a window into the collective mind of the online STEM learning community.
Yeah, it's fascinating to see what topics people are searching for and engaging with.
The first thing that jumps out at me is just the sheer diversity of these tags.
Hmm.
You got everything from basic concepts like measurement and primary
Right.
to more advanced topics like dynamics and electromagnetism. It's like a snapshot of the entire spectrum of physics education.
And it aligns with what we've been discussing.
Yeah,
This website caters to learners of all ages
right.
and levels of expertise. So whether you're a primary school student just starting to explore the world of physics or a university student diving into complex concepts,
Right.
there's something here for you.
I'm also intrigued by the inclusion of tags like biology and junior college.
Yeah.
It suggests that the website's reach kind of extends beyond just physics enthusiasts.
Absolutely. It seems like they're trying to foster a love of STEM in a broader sense, recognizing that these fields are often interconnected
Right.
and that understanding one can enhance your understanding of others.
The fact that Superposition 1 is listed as a popular tag is also really interesting.
Yeah.
It kind of validates our initial observation that this is a concept that people are actively seeking out and trying to understand.
It's not just a theoretical concept confined to textbooks.
Right.
It's something that has real-world implications and applications, and people recognize that.
Speaking of real-world applications, one tag that caught my eye is easy JavaScript simulation.
Oh, yeah.
It seems to indicate a demand for simulations that are not only educational, but also accessible and easy to use.
And I think that speaks to a larger trend in education,
Mm.
the move towards more interactive and engaging learning experiences.
Right.
People don't just want to passively absorb information.
Right.
They want to actively explore and experiment.
Right. And the fact that these simulations are built using JavaScript, an open source language, makes them even more accessible.
Right.
Anyone can potentially modify or adapt them to create their own custom learning tools.
It's a fantastic example of how open source technologies are democratizing knowledge and empowering people to take control of their learning.
Another tag that stood out to me was Moodle data.
Oh, interesting.
For those who aren't familiar, Moodle is a popular learning management system used by many schools and universities.
Yeah, it's a platform for creating and delivering online courses.
Right.
And the fact that this tag is present suggests that these simulations are being integrated into formal educational settings. That's really exciting to see.
It speaks to the quality and educational value of these simulations. They're not just fun little experiments, they're being recognized as valuable tools for enhancing teaching and learning in a variety of contexts.
And it highlights the evolving landscape of education technology is playing an increasingly important role in how we learn and teach. And websites like this one are at the forefront of that transformation.
The tag SYPT, which we talked about earlier, is also noteworthy. It represents the Singapore Young Physicists Tournament, a competition that encourages students to tackle challenging physics problems and present their solutions.
It's great to see a website that supports not only casual learners, but also those who are pursuing STEM at a competitive level.
And the inclusion of tags like Chinese language speaks to the website's global reach and commitment to making physics education accessible to a diverse audience.
It's really inspiring to see how a single website can bring together people from all over the world, united by a shared passion for learning and exploring the wonders of science.
As we wrap up our deep dive into superposition, I wanted to circle back to something you mentioned earlier. The idea that superposition isn't just a concept confined to textbooks. It's something we experience all the time without even realizing it. That really got me thinking.
It's true. Superposition is woven into the very fabric of our reality.
So to our listeners out there, I want to leave you with a challenge as you go about your day-to-day. Try to see the world through the lens of superposition. Listen to the music you hear, observe the colors around you, and think about how those experiences are shaped by the interactions of countless waves.
And remember, the world is full of hidden wonders waiting to be discovered. Don't be afraid to ask questions, explore new ideas, and let your curiosity lead you down unexpected paths.
We hope this deep dive has sparked your interest in superposition and given you a new appreciation for the beauty and complexity of the world around us. Until next time, happy exploring.